Hello and welcome to today's webinar on IR-Link. I'm Dimitri. I'm the National Development Manager for Automation, Control and Industrial IoT for HYDAC Australia. And today's webinar will be about IR-Link and will be presented by my colleague Joachim Meiser, who is the Product Manager for HYDAC Electronics and is based in our German headquarters. The webinar today will be on what is IR-Link, the benefits of IR-Link, and the products in our IR-Link portfolio. And if you have any questions, please write them down and we will answer them at the end of the webinar. And now I'll pass you over to my colleague, Joachim Meiser.
Thank you, Dimitri, for the introduction. What is IO-Link? IO-Link is the first and worldwide standardized I/O technology, which is fixed in a form. IO-Link is a bidirectional communication system linked to smart sensors and actuators for connect sensors and actuators to a PLC or automation system. IO-Link is a point-to-point communication, and IO-Link can communicate with an IO-Link master to automation systems. If we got, for instance, a pressure sensor, we have a fluid port and a sensor cell. And if we have an analog style installation, we have to convert the analog signal from the sensor cell to digital data. With the digital data inside of the processor from the sensor, we can make the temperature correction and everything. And after that, we have to convert again the digital data in an analog value. This analog value we transmit with shielded cable directly to the cabinet where the PLC is located. And there we convert again the analog signal to a digital value. Let's recap that on the slide. Here you see the sensor cell, which is an analog style. Then we have to amplify the analog signal. This amplified signal we convert to a digital value. We process that and correct the temperature failure and make it more accurate. And now in the standard analog installation, we have to convert this again in the analog value. Therefore, we have to use shielded cable. With the shielded cable, we can transmit the analog values, for instance, a 4 to 20 milliamp signal directly to the cabinet, which you see here. In the cabinet, we have the mentioned analog digital converter, which is directly linked to the PLC. In an IO-Link installation, we got the analog sensor cell as well. We need to amplify the analog signal from the cell, and we can convert the analog signal directly to digital values to work with them in the sensor. So we have again the controller, the microcontroller, and we do all the corrections inside of the sensor. But now we see the change. With the IO-Link installation, we don't convert again the digital value back to an analog value. We transmit directly digital data to the IO-Link master. We can use for this standard cabling, which have the M12 connector. So the components of a standard IO-Link installation are IO-Link sensors or actuators, unshielded cables, and an IO-Link master. The data that you get from an IO-Link sensor are the process data, like the value of the pressure, the temperature, humidity, diagnostics data, like error messages or warnings. You get the state of the data. Is the data that you get validated? And you have some additional values like the part number or data sheets. IO-Link cabling is less expensive and simple. In the past, you have to use many different kinds of cable, like multi-core cable and such other really expensive stuff. Now with IO-Link, you can use standardized and known cable with a standard M12 connector. This reduces costs in many cases. One cable fits all. If you connect an IO-Link sensor to a master, the master will recognize that and will read out the type and the serial number of the sensor. After that, the master can write down the parameter setting directly into the sensor. So there is a bidirectional communication between the sensor and the master. This behavior will reduce downtime of all your production lines. In the past, skilled people have to replace and replace the sensors, a failed sensor, for instance, and they have to set up the exact parameter settings in the sensor. With IO-Link, the master will recognize there is a new and well-working sensor installed, and he will recognize them and write down directly the right parameter setting. But you got some additional functions from IO-Link also. You can have some diagnosis data. The sensor can tell you more than only just the pressure, for instance. It can tell you, oh, there's low voltage, I got over temperature, or I have seen many times over pressure. There's a problem in the production line. But one of the biggest benefits for IO-Link installation is it is almost plug and play. You see here an IO-Link master, and you see the M12 cable connectors versus the old-fashioned style where you have connected the multi-core cables to the old terminal installation, which can cause a lot of human failures during installation and later on, and it makes it really difficult to find any problems or issues in the application. That all leads you to a lot of customer benefits. It will reduce downtimes. It will make your applications more simple, and you have a centralized storage of the parameter settings. The end user doesn't need to bother with the center parameterization because he can just simplify, exchange the sensor, and the IO-Link master will do the rest for him. Here you see some IO-Link examples. IO-Link is useful in machine tools, pulp and paper, wind power, hydro power, steel plants, or condition monitoring applications. Condition monitoring applications can be used in all stationary applications. This is a small picture of the HYDAC electronic sensor range with IO-Link interface. We have added some additional smart features to some of them. So IO-Link is one approach to the Industry 4.0. It is not Industry 4.0 itself, but it can be one way into Industry 4.0. Any questions so far? So the first question, does IO-Link have Bluetooth capability? And if not, will this become a feature in future? As far as I know, Bluetooth is not really related to IO-Link sensors. So I don't know what the future will bring, but at the moment I would say no. Can we replace existing analog sensors with IO-Link sensors in the field? Yes and no. If you want to replace an analog sensor in the field, you have to install an IO-Link master. If you do that, so the answer is yes. So if you want to replace the analog sensor, you have to take, it's not useful to change over only one sensor. You have to work out and refurbish the whole system, and then you can install the analog sensors or replace the analog sensors with IO-Link sensors. This is, by the way, this is a good question, because IO-Link can be the way to bring the brownfield installations to the IoT section. Okay. Oh, there's another question. Oh, can the IO-Link master be integrated into a HART system? No. No. IO-Link and HART are two completely different interfaces. They cannot talk to each other so far. And another question. Is it easy to program the IO-Link master, or is it needs special know-how? The IO-Link master provides his own web interface, and yeah, I would say it's not that really difficult to make the parameter setup. If you've done it once or twice, I think it can become easy for you. So there are no questions so far. Thank you for your attention, and I will hand over to my colleague, Dimitri.
Thank you very much, Joachim, for making the time to present that. If you have any questions or would like to get some more information or more technical data, yeah, please don't hesitate to email me. You'll find my contact details. Thank you very much, and hope you all have a great day.